Hello, good morning everyone, and once again welcome to Mathematics Galaxy. In today's video, I am going to discuss about the definiteness of a real quadratic form. That is, when a real quadratic form is said to be positive definite or negative definite or positive semi-definite or indefinite. So let's get started. Let me write down the points. Let Qx be a real quadratic form where x equal to x1 x2 dot dot xn. Then the quadratic form qx is said to be positive definite. That is then qx is said to be positive definite if qx is greater than equal to 0 and qx is equal to 0 if x equal to 0 0 0 0. That is, for only x equal to 0 vector qx is equal to 0, otherwise qx is greater than 0. Okay, then the quadratic form is said to be positive definite. Then qx is said to be positive definite. Okay, and the quadratic form qx is said to be negative definite if, so please note down this particular point of positive definiteness. Next we will move on to the next point of negative definite. Okay, the real quadratic form qx is said to be negative definite if qx is less than equal to 0 and qx equal to 0 if x equal to 0. That is, for x equal to 0 vector, the quadratic form qx equal to 0, and otherwise the quadratic form qx is less than 0. Then the quadratic form is said to be negative definite. Said to be negative definite. So I have made the changes. I have made the required changes for negative definiteness of the quadratic form. That is, the quadratic form qx is said to be negative definite if qx is less than equal to 0 and qx equal to 0 for only for x equal to 0 vector. Then the quadratic form qx is said to be negative definite. Now let's move on to the next point. The quadratic form qx is said to be indefinite if qx is greater than 0 for some x and qx is less than 0 for some x. Then the quadratic form is said to be indefinite. Okay, so let's move on to the next point. That is, the quadratic form is said to be positive semi-definite. a quadratic form qx is said to be positive semi-definite if qx is greater than 0. Quadratic form qx is said to be positive semi-definite if qx is greater than equal to 0 and qx equal to 0 for some x not equal to 0. That is, for some non-zero vector x, if qx equal to 0 and otherwise qx is greater than 0, then the quadratic form is said to be positive semi-definite. So let's note down it formally. Qx is said to be positive semi-definite if qx is greater than 0 and qx equal to 0 for some non-zero x not equal to 0. This 0 is a 0 vector, okay, that is x not equals 0 vector. This means this, okay. And next point is when the quadratic form is said to be negative semi-definite if qx is said to be negative semi-definite if qx less than equal to 0 and qx equal to 0 for some non-zero x, that is for some non-zero vector x qx equal to 0. That is, for positive semi-definite for some non-zero x qx equal to 0. Otherwise this condition is same as the positive the condition of positive definite. Similarly, for negative definite for some non-zero x qx equal to 0 and otherwise the condition is same. That is, for negative semi-definite qx is less than equal to 0 and qx equal to 0 if and only if x equal to 0 vector. That is, for only 0 vector qx equal to 0, otherwise it is negative, then it is negative definite. For only for the 0 vector it is equal to 0 and otherwise the quadratic form is positive, then the quadratic form is said to be positive definite. But here for positive semi-definite qx is greater than equal to 0 and for some non-zero x qx equal to 0. Okay, this was the topic for today. So thank you for watching this video. Okay.